Relations and functions. In this section, we're going to look at determining if something is a function. If something is a function, that means what we're trying to see is there exactly one value of y for every x value. To do this, when we have a graph, we can use a vertical line. I'll use the marker as a vertical line. If I place my marker on our first graph right here, what we're looking to see is, does the graph hit the marker at only one spot whenever I trace it along the function? And the answer here is no. It hits at the top and it hits at the bottom for multiple places where I could put the marker. So this does not pass the vertical line test. This means I cannot put a vertical line everywhere on our graph and have the graph only hit the vertical line one time. So what this means is, for each of these x values, there's more than one corresponding y value. That makes it not a function. So this graph here, that one's not a function. Let's try this one. Is this a function? Well, we have to be very careful. Right here, it looks like it might hit twice, but if you look very closely, this is an open circle, and this is a closed circle. So that means that here we're not actually using our value. Here we are using our value. So x equals 0 is right here, not right here. So this one, same thing, right here, this is an open circle. So as we move this across, this is going to be a function. This does represent a function. Let's look at the domain and the range. If we're looking at domain, we are considering all of the x values that are used. So looking at our first graph right here, if we're looking at the domain, we're looking at all of the x values that are used. So we can write this out. In this case, the domain. Well, let's see what's used. So remember, these are the x values. So as we look across, well, let's see. I have an x value right here. It has an x coordinate of 1. 1 is used. X equals 2 is used. X equals 3, 4, 5, and it looks like 6. So our domain is 1, 2, 3, 4, 5, 6. Now we would not write this as 1 through 6 because 1 is used, but 1.1, 1.2, 1.3, those are not. They don't have a correlating dot. So we have to write out, in this case, the ones that are used. We can look at the range. Range correlates to y. So same thing, let's look at the y values that are used. So here we have our range right here. Well, this one has a 3, this one has a 1, this one has a -1. Here we have 0, here we have 2, and here we have 6. Usually you list lowest to highest. So let's see, we had -1, we had 0, we had 1, we had 2, we had 3, and we had 6. So that would be our range. If we look at our next graph, this time we have a continuous function. That means that our function is connected and it is a continuous line from start to finish. So let's look at the same thing. Let's look at our domain and let's look at our range. So the domain is all of the x values that we use. So this one, notice the arrows on the end. So this keeps going, this keeps going. So this would go all the way down on our x-axis. Remember, the x goes out this way. So as this would continue to go this way, the function would continue to go down. So we're going to use everything to -infinity on our x-axis. Same thing over here. As our x increases, the function would keep going. So infinity. Does this pass our vertical line test? It sure does. It's only passing through one time. So this one is a function. Now we need to consider our range. So our range looks at the y values that are used. So starting in the low, we have all the way down here, all the way -infinity, all the way up, 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 up to right here. So our y value right here at the top looks like it's going to be 4. So for the range, we have -infinity all the way up to 4. But notice it does not go above 4. So 4 is the end. We can use 4, so we'll give it our hard bracket. Let's look at our third graph. This time we have a circle. Well, let's look at the domain first. The domain is all of the x values that are used. So if we go all the way over to this side, it looks like -5 is the end of the x's that are going to be used. But we can use -5, so let's do our bracket. And then going this way, all the way over, it looks like 1 is going to be our stopping point. Same thing for the range. All the way down, it looks like we have -1. And then up to the top, it looks like 5. Now, is this a function? Does it pass our vertical line test? No, it does not. So this one, the circle, is not a function. Let's look at some more domain and range calculations. Let's say we have y equals 6x plus 8. And we want to find the domain, and we want to find the range. So let's look at this. This is going to be the graph of a line. We don't know exactly what it looks like, but we know that this is y equals mx plus b format. We know our y-intercept is 8, so maybe it looks a little bit like this. This is going to be a line. As we continue for the x's in either direction, the line will keep going. So our domain is -infinity through infinity. As we continue for the y, the line's going to keep going. So our range is -infinity to infinity. Let's try again. Say we have y equals 2 over x minus 4. So now we need to think about our domain. Well, we have a fraction here. When we look at fractions, there's one case in the denominator of something that we cannot have, and that is division by 0. So that means that x minus 4 cannot equal 0. So x cannot be 4. That's called a restriction to our domain. Well, if x cannot be 4, that means our domain can be everything else except for 4. I can't use 4, but I can use anything to either side of 4. So -infinity all the way up to 4. Now we can't actually use 4, but we could pick up at 4.0000000001 and continue all the way through infinity. So it'll look like this. So then let's look at our range. Well, I cannot have division by 0. Well, if I can't have division by 0, right here, that's going to impact our range as well. So for our range, there we go. Let's try again. Let's say we have y equals the square root of x plus 3. There's a special case for when we have a square root. Remember, you cannot have a negative under the square root. So that means that x plus 3 has to be greater than or equal to 0. This is what's under our square root, x plus 3. So x plus 3 from under the square root has to be greater than or equal to 0 so that we do not get the square root of a negative number. So that means that x has to be greater than or equal to -3. Well, that tells us our domain. If we want x to be greater than or equal to -3, then our domain is -3 through infinity. So how is that going to impact our range? Well, the smallest piece of our range is -3. So let's put that in. So if we have y equals the square root, our smallest x value is -3. Oops. So negative 3 plus 3 gives us the square root of 0. Well, that's just 0. So correlating to our negative 3 as our smallest value, when we put the negative 3 in, we get 0. So our range is going to look like 0. Now, if we were to put infinity plus 3, the square root, that's going to keep going all the way to infinity. So that would be our range.